guess we might as well just dive right in. So let's take a look at 38, growing plant. Let's see what it's asking us about. All right. So basically we've got this plant and it seems to grow at kind of a regular speed. So each day it goes up speed meters. And then it goes down by down speed meters. Okay, so basically the plant is going up by this number of meters each day, and then at night it goes down by this amount. So like in the example they have down here, I guess this plant is growing 100 meters a day. I don't know what kind of plant this is, but anyway, so it's growing 100 meters a day, and then it's shrinking 10 meters at night due to the lack of sun heat. Okay. And we're to make the assumption that the plant starts at a height of 0 meters tall. So I guess it's growing from seed. And I'm planting seed at the beginning of a day. We want to know when the height of the plant will reach a certain level. And that certain level is desired height. Okay, so basically if we're talking about an example like this, it's going to go up by 100 each day, and then it's going to go down by 10. So effectively, it's kind of like it's going up by 90 each day, but it's kind of important to recognize that it does go up by 100 first and then go down by 10. And the reason that's important is because if we were looking at it the other way, like if we were just saying, okay, forget about there being an up speed and a down speed, let's just say it's going up by 90 each day. Well, after 10 days, then it would only be at 900. So if it's going for 10 days, or if we wanted to get to 910, we'd have to throw on an 11th day. But the important thing is because it's going up by 100 first, and then it goes down by 10, it actually only takes 10 days to get to 910. So we'll look at sort of the subtleties of that as we continue here, as we go further. But I guess for now, we might as well get started. And of course, I'm going to try to attempt this in the most literal, naive possible way. So I guess one way we could start would be to actually create a plant, right? Or at least we'll make something like it. We'll make an array. And just like the growing plant here, the array is it's gonna grow every day. It's gonna go up by, or it's gonna get up speed many new entries, right? So maybe 100 new entries. And then we're gonna take away 10 entries or whatever down speed is. Okay, so that's basically the goal. And we're gonna go through a loop. We're gonna say for let day be assigned the value of 1, and nothing in the middle. We're not gonna check for anything. The reason we're not checking for anything here is because I'm going to finish off the function inside the loop. Basically, as soon as we find which day it was where we actually reached desired height, that's what I'm going to return. And keep in mind, I'm using a let in front of my day variable here. So that means day wouldn't even be accessible outside of this loop anyway. Okay, so we kind of have to return it from here unless we wanted to either make this a var or declare it outside the loop or something else like that. But I think this will work fine. And I mean, you'll see what I mean in just a sec if it's not clear right now. So basically what I want to do is inside this loop, I'm going to add new entries to plant. How many new ones? Up speed. That's how many. And then I want to check if the length is greater than or equal to desired height at that point. Because if it's made it there, if it's made it to the height that we're looking for, great, we'll return it. And then afterwards, if we haven't reached that, then we'll subtract entries from plant. And that might be a little tougher, but we'll find out. Down speed is how many we're going to subtract. Okay, and that's basically going to be our game plan. So we'll do one of these at a time. And I guess we might as well start by adding the new entries to the plant. Okay, so we could do something like, plant.push. What do we want to use to represent a unit, a meter? Maybe we'll just use a hashtag. Okay, so we want to push a hashtag. And we kind of want to do that like a number of times. So like we could say for let I be assigned the value of 0, I is less than up speed, I++, and then, yeah, basically just do this inside of the loop there. So we're going to push the hashtag. Okay, and then let's see. Basically, if we reach a point here where, I'll do it this way, if plant.length is greater than or equal to desired height, well then we're going to return day. We're going to return whatever day that happened on. And then at the end of this, we're going to say plant.splice. Not plants, plant. So you remember splice? In case you don't, splice is something that's, it's an array built in, so it's going to work for arrays. And it's what we want to use when we're trying to cut something out of an array and maybe replace it with something else. But the main thing is we're trying to cut something out of it. And there are other ways we could do this. We could use a slice if we wanted to, and maybe that's the better way to do it, but I'm going to go with a splice for now. So we're going to say, all right, where do you want the splice to begin? The things you're going to cut out, where should we start? What index should we start at? I'm going to say 0. They're all the same thing. It's all just a bunch of hashtags. So I don't think it really matters where we start this, but we might as well choose 0 so that there's going to be at least enough things to take away from there. So how many things do we want to take away? Like, what's the number of entries we want to be removing from the array? Well, down speed. That's how many entries we want to remove. And do we want to replace it with anything? Like for a third argument here, you know, do we want to put in like, I don't know, a 0 or something like that? Well, no, we don't want to put anything in its place. We just want to take it away. Okay, so I want to do, well, actually, okay, let's run the tests, run the sample test, and great, look at this. It passed both of the 2 tests we have here. We don't have a whole lot to go on here, so, all right, great. Well, that's nice. Now I want to do a quick thing over here. So console log, and I want to take a look at what plant is looking like when we do this. So, okay, maybe this is a bad example because upspeed is 100. That's going to be hard to count. Upspeed is 10 here. That's a little more reasonable. So, yeah, basically we have 10 after the first set of pushes here. But here we're just kind of like pushing one at a time. It's like push, 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 right? And check it out. So I actually want to return plant up here because I want to show you something. Plant.push. This is, I actually don't know if this is like a well-known fact, but if you want to push more than one thing, so let's say we wanted to push 2, and then we wanted to, oops, we want to push, let's say 5, and then it should be the array containing 2 and 5. Great. But now let's say, like, you know, could we do it like this? Could we just have 2 arguments and we're pushing both of those into the array? And yeah, as it turns out, totally, you can. We could even put these in an array, but the thing is, now we're actually pushing an array, so it's an array within an array, kind of like we're getting into matrix territory if we're doing that kind of stuff. So if you do want to put it in from an array, be sure to spread it. So we'll use a spread operator, put the ... and now the 2 and 5 are just being pushed in there the way we want them to. Okay, so the reason I'm mentioning this is because basically we've got this thing happening, right? We've got our for let I be on the value of 0, I is less than upspeed, I++, we're pushing one of those for each time, you know, we're pushing upspeed, we're going through this whole loop. And I'm just going to say, let's not loop it. Instead, let's just do a repeat on this thing. So we'll repeat upspeed. But now the thing is, this repeat, well, okay. Should I show you what's wrong with this? No, actually, this won't even complete because it's basically just going to take one really long string. Like this is going to be a string with 100 characters in the first example. And then it's going to push that into the array. And then it's going to remove like 10 things from the array. So there isn't even going to be 10 things to remove. This, I think, would loop infinitely. And so basically the idea here is that we don't want a string with 100 characters in it. We want 100 separate characters, right? So we could do like a dot split on this. And then since that's now an array, we'll do a spread operators. And that should work the way we want it to. Great. So this is basically just inserting, in the first case, 100 new hashtags, 100 new meters onto our plant. Thing is, as it turns out, the spread operator, the ... over here, is something that works on I think the general class of these objects is called iterables. So it's going to work on an array, but it's also going to work on a string. I don't actually need the dot split here. So I can just push dot dot dot, hashtag dot repeat up speed. So basically single character, the dot repeat just repeats that however many times. We want it to repeat up speed many times so that there are that many of these things. So whether it's 100, whether it's 10. And then it wants to push each one of these as a separate entry. That's why we put the spread operator, the dot 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 in front. Okay, cool. So that's working, right? I mean, I don't think we've actually tried the hidden test. So maybe let's just, let's give that a shot. Let's see if it passes all of these. And look at that. Sure does. So that's nice. We're oh hey, look at that. Thanks. That's really nice of you to say. But not right now. We've got other ways of doing this problem that we want to take a look at. So okay, nice job. I mean, this worked. We're sort of simulating it. But now let's say we don't want to use an array, because if you think about it, like we've got this array here. We're taking this string and like splitting it up into entries for an array. We're doing a splice at the end here. I'm thinking maybe there's a way we could do the same thing. So actually simulating this, actually having something representing a plant, except instead of using an array, let's now just make it a string. So instead of plant.push, we'll just say plant plus equals, and we don't need to spread that out anymore. It's just part of the string we're looking for, right? So plant plus equals, hashtag dot repeat up speed, great. And then this part where we want to take some of these away, we'll just say plant is assigned the value of plant dot slice at down speed. Okay, so the reason I'm doing it this way, the reason I'm saying dot slice at down speed is because that means it's, okay, so the slice is going to take a string that's, you know, some slice of this original string. It's going to be the slice that begins at the index down speed and ends at the end of the string, wherever that happens to be. So since it starts at down speed, it's basically getting rid of all the elements before that. So if down speed was, let's say 3, okay, then how many elements are there before index 3? Well, there would be 0, 1, and 2, so there are 3 of them. So this is a good way of getting rid of the first 3 elements, or the first, you know, whatever down speed is, elements. Okay, so let's try that. You know, maybe that'll work just as well. Yeah, it does. I mean, dot length is the same as what we want here. Slice would work the same for an array. So I think this is just a little nicer. So we'll roll with this one for now. I think it's going to pass all the hidden tests as well. Yeah, just as good, maybe even better. I think in general, a string takes up less memory than an array, but I don't know. You'd have to ask an expert for something like that. So, okay, that was a good attempt, but now let's do it in another way. You know, on the topic of memory management, I feel like, yeah, probably using a string is better than an array, but if we can avoid using either of them, well, that's probably the best possible. So let's try that, I guess. So now, instead of like creating a string or an array or some other kind of iterable and then measuring its length, let's just keep track of the length. So in other words, we can say let height be assigned the value of 0. And then we'll do the same sort of thing. We'll say for let day be assigned the value of 1. No condition for continuing because it's still going to end within the loop. And we'll increment day each time. And we'll just say if height plus up speed is greater than or equal to the desired height. So if when we add the up speed after it grows for that day, if we're going to get to or exceed the desired height, well, then we're good. You know, we found the thing we were looking for. Let's return day in that case. And if you didn't, then we'll just say height. Ultimately, the way it's going to change is it's going to go up by up speed, but then it's going to go down by down speed. And so we're going to add on to it kind of like the difference between the two. Okay, so let's try that. We've got a return statement in here. It should be guaranteed to work. Okay, great. And by the way, when I say that this is guaranteed to work, it's important to note that they're always going to give us a down speed that's strictly less than up speed. So that means ultimately, like, this is positive. You know, up speed minus down speed is always going to be positive. Height is ultimately going to be going up over time. It might be a really long time, but it is ultimately going to be going up over time. And that's kind of the important thing here. Okay, so did that pass the hidden test? Did we try? Let's try. Let's see if it works. It works. Okay, and maybe that's not a super huge surprise or anything like that, but I mean, it's better than what we had before. It's getting a lot simpler. This one is no longer keeping as much in memory. It's basically just using a single number to represent the current height, so we're not having to measure the length of something. We're not, like, you know, the size of this thing isn't getting a lot bigger when our variables get bigger, like when our inputs are bigger. So it's getting better, but maybe it can get better than this, because I'm sort of thinking about this. I'm thinking about the type of growth that's happening here. And I'm thinking, if height is just increasing by this same thing every time, then that's constant, you know, it's just going up by that amount each time. So if, you know, like in this case, up speed minus down speed would be 90, right? So it's just going up by 90, going up by 90, going up by 90. Every time it's just going to go up by 90. So that's kind of like a linear relation, if you think about it, right? So we've got something that's going up that has like a slope, so to speak, of up speed minus down speed. And we want to know that line that has a slope of up speed minus down speed, when is it going to reach desired height? Or at least, when would it be reaching desired height if we were adding up speed to it? So in other words, it's kind of like this. I mean, we've got this whole height thing that we're kind of tracking the growth of, and it's kind of like this, actually. Like, this would be the same thing. Height plus up speed is greater than or equal to desired height would be the same as saying height is greater than or equal to desired height minus up speed. Okay, so that's kind of interesting. So what we can do for something like this is we can create a linear relation. We can make an equation of a line for this thing. And so I guess we'll let y represent the height. We'll let x represent the day. So we could do something like, or actually maybe we'll just use H and D. Let's go with a neat color that we don't often use. Maybe like a pale forest green. Yeah, pale forest green. Okay, so normally we've got equations that look like this. Y equals mx plus b. Sorry, I have a new mouse, and so this is kind of more sensitive than what I'm used to. Might take me a little while to adapt to writing with it, so sorry about that. Thanks for understanding. In this case, we're looking at this, and geez, I need another color to go with this. Yeah, let's go with like a nice washed out kind of lavender. All right, so y equals mx plus b. Now, normally this would represent the slope. It's how much it's going up by each time. And this over here, it would represent the y-intercept. Okay, so what are we doing for this thing? Well, basically the idea is that for y, we're going to have h, right? It's going to be our height. For m, well, that's the slope. It's going up by this each time, right? Up speed minus down speed. So maybe I'll just do in parentheses something like a up minus down. I guess I could have just used u and d or something like that, but oh well. And then for x, we're going to have d. Okay, so that's why I used the whole word. Anyway, d for day. And then plus b. Well, that's maybe worth thinking about. What is the y-intercept here? And let's see. I guess it would sort of be like, zero. Would it be zero in this case? Or would it be something else? I mean, there are a few ways we could sort of think about it. We could say it's zero, but then the issue here is we're sort of starting the day at 1. So, maybe we'll say it's going to be, yeah, okay. Here's the thing. So since the day starts at 1, that means at 0, we would have this much less. You know, like this is how much it's going up from 0 to 1. So this would be kind of like, or at least negative this would be sort of like our b value. So minus up minus down. Okay, so sorry, that got a little complicated in there, but that's basically the formula we want to use. So, okay, yeah, that's basically it. Let's transfer that over here. So we had something like this. It was h equals, and we had up speed minus down speed, down, times d for day, minus up speed minus down speed. And that's just because since it's a y-intercept, it has to be the value that we're going to have when d is 0. So keep in mind, when d is 1, we want h to have a height of 0, right? On the first day, it should have a height of 0, and then it should go up and down and all that fun stuff. But because of that, that means on day 0, this would have to happen. We'd have this y-intercept here. So what we want to do in this case now is we're given the height, we're sort of given like the desired height, right? That's part of what they provide in the problem. They give us the desired height. What we want to do is find the day where that occurs. So this right here, this d value, that's kind of like the unknown in the formula. So we shouldn't have h isolated if it's really d that we're trying to solve for. So let's try to isolate this. Now, let's see. Yeah, okay. So one more thing I want to say. It's probably worth mentioning right now. So I was saying that we will use desired height for this, but then I realized, well, there's this whole note about this though, right? Height is greater than or equal to desired height minus up speed, right? And that's just because it's going to go up by that amount, and then afterwards it's going to go down by down speed. So we need to check when it goes up by up speed, and before we subtract down speed, has it reached the height that we're looking for? So for our desired height for h here, we're going to use desired height minus up speed. So dh, I guess, for desired height. Yeah, okay. Minus up speed is going to be equal to up speed minus down speed times d for day. And then I'll just distribute the negative into these, so we'll get minus up plus down. I don't know if you have any questions about why this is a plus here, but basically the idea is that we're subtracting a negative, which is the same as like adding a positive. Okay, so desired height minus up is equal to up minus down times d minus up plus down. Well, first thing to notice here is that we could add up to both sides. We've got desired height minus up. We've got a minus up over here as well. So we could just sort of get rid of those by effectively adding up speed to both sides. Okay, and then the next thing I want to do is just to sort of get rid of this over here, because we're trying to isolate d, right? So I want to get rid of some of the stuff that's on the right side. So we're going to subtract down speed from both sides, and we'll do the same thing on this side as well, because an equal sign is like a balance. We've got to keep it balanced on both sides. So desired height minus down speed is what we have now, down, and that's equal to, well, basically what's left over here, just the up minus down times d. So we'll put that in there, up minus down times d. Okay, so basically at this point, we want to get d on its own. We're going to divide both sides by up minus down. I really should have just used single character variables for these, because then we'd probably be able to read it. But anyway, the point is we've got d on its own, and it's going to be equal to desired height, dh, minus down speed, down, and all of that is being divided by up speed minus down speed. Okay, cool. So I guess that's what we're looking for, right? Days are just going to be desired height minus down speed divided by up speed minus down speed. So let's try that. I guess we should get rid of all this stuff first. And we're going to archive this very nice solution. It served us well. We'll get rid of some of the space in between so we don't have too many white space characters or anything like that. And then we want to return. What was it again? It was desired height minus down speed, I think, divided by up speed minus down speed. Was that right? Let's just get in there and let's check on that. Yeah, desired height minus down speed over up speed minus down speed. So let's give it a try. See where that takes us. And okay, so there's a bit of an issue here. The first issue is this. So if we have an up speed of 10 and a down speed of 9, the desired height is 4. This is telling us that we'd actually reach that at -5 days. So like 5 days before we even start this experiment, before we even start planting the seed, we already have reached our goal. So that's not really great. The reason we're getting that is because we're basically continuing this past its domain. So maybe we can get a visual for that. So we had this desmos.com. We had an up speed of 10 and a down speed of 9. Is that what it was? Let's see. Yeah, up 10, down 9. And the desired height was 4. So let's get that in there. And we want y to be desired height minus down speed, right? So minus v down, v for velocity. Okay, yeah, and there we go. So we're basically saying, hey, when is this thing going to be equal to -5? And yeah, at -5, that's when that happens. So the thing is, we want to start our observation right here. We want to start our observations on day 1. If it happened before that, well, okay, we don't really want to get into that. So basically, we'll say math.max 1 or the other thing. Okay, so basically, if it would normally be a negative number or 0 or something like that, then it's going to round it up to 1. Because that 1 would be the maximum in that case. Otherwise, if it's some other thing, that's already going to be greater than 1. So, you know, the max there will be whatever that thing greater than 1 is. Okay, so let's run this. And now we're solving both of these. Let's see if we can submit this and get the hidden test. We got one of them. We didn't get the other one. So let's try to figure out what went wrong here. All right, we'll get into some other values here. Let's say up speed of 5, down speed of 2, and we want our desired height to be like there, perfect, 13. Okay, here's the thing. So notice, when is this thing getting here? It's somewhere between the 3rd day and the 4th day, right? So this, if we were to just return this, it would be like, 3.67 or something like that. That's not really good, because in the problem here, we're looking for a whole number. The output is supposed to be an integer. So since we're looking for a whole number, we're going to have to round this. We could do like a math.round on all this stuff over here. Or we could do like a math.floor or math.ceil. But let's take a moment to think about what makes most sense here, because this is where the thing is happening, right? So it's mostly through the 3rd day. So, it's the 3rd day, 2/3 towards the 4th day. So we would want to say that that's more like the 4th day. It would take 4 days for it to have reached or exceeded that desired height. So really, it makes sense for us to round up in this case, which is why we're going to use a ceil on this and not a round or a floor. So math.ceil, let's run the sample tests on this. We'll see if at least we're passing the visible ones. And then if that turns out to be the case, which it is, we'll try submitting and we'll see if we pass the hidden ones with this. And we do. Okay, so that's nice. It's a good feeling. And what I really like about this one here is it's a nice big O1 solution. It doesn't really matter how big our numbers are here. I guess we probably don't have to worry too much about that, because it's not like these are going to be too out of hand or anything. But Still, it's nice that this doesn't depend on loops or anything like that. The time it's going to take is going to be just a constant thing. So, okay, let's actually formally submit that now that it's got the big O of 1. And actually, I just noticed this little space here, this sort of thing is going to bug me. So let's submit it again, and that'll be it for this one. So, great. Nice job, everyone. Let me know if you have any questions, comments, or concerns. And I guess we'll move on to the next one for now. But before we do, we're going to take a little break.